does.
Multiplying vectors by scalars will allow us to dilate or expand or contract the vectors, and in the case of multiplying by a negative number, change their direction. So if we take a vector, let's call it vector u, that starts at A and ends at B, and it has a components of 4i plus 3j, 4 in the horizontal direction, 3 in the vertical direction. And we want to multiply this vector by a scalar. And remember, a scalar is just a number. A single number we're going to multiply the whole vector by. Let's see what happens. Let's multiply this vector u by 2. So we're going to create a vector that's a vector v that's equal to 2 times u. So v is equal to 2 times u, and that's this green vector here. What we can do is we distribute the 2 to each of the two components. So it's 2 times 4i plus 2 times 3j, which is equal to 8i plus 6j. The new vector has a horizontal component of twice the original one, of 8i now, and it has a vertical component that's also twice the original, 6j. Notice it has the same direction, and also notice twice the magnitude. So the vector v that is 2u is equal to exactly twice the original vector. It is now 8i plus 6j. Now let's multiply u by negative 2. We get a vector w that goes in the opposite direction of the original vector. And w is negative 2 times u, which is going to be negative 2 times the quantity 4i plus 3j. So we distribute that negative 2 to both components. Negative 2 times 4i is negative 8i. Negative 2 times 3j is negative 6j. So a vector that is multiplied by a negative number winds up going in the opposite direction 180 degrees or pi radians away from the original direction with exactly. So vector w, which is negative 2 times the original vector u, goes in the 180 degrees away from the original vector at twice its magnitude. So negative changes the direction, number changes the magnitude and components of the vector by that factor. So let's look at both these from the original. Both vectors dilate the original vector by a factor of 2. That's a scale factor. In fact, that's where the term scalar comes from, scale factor. Notice the original the first dilation of vector v goes in the same direction because it's multiplied by a positive number, and vector w, because it's multiplied by a negative number, has an additional transformation of rotating the vector by 180 degrees or pi radians because it's multiplied by a negative number. And here's what a little bit of vector physics can get you. So scalar multiplication of vectors, like the vector u that is xi plus yj, is done by multiplying the scalar by both components. If the scalar is a number k and we want to find k times the vector u, it's going to be k times the horizontal component plus k times the vertical component. So the components multiply. And this is true for the magnitudes as well, as you saw in the example. If we multiply a vector by a scalar, the magnitudes multiply by the scalar as well. So a vector v that is k times u has both its components multiplied by the scalar, which is k in this case, and the magnitude multiplied by the scalar. Now just a note, magnitude has to be positive, so if it's a negative number for k, the magnitude is still going to be positive, so we're going to have to take the absolute value of that. Let's look at an example. Let's take a vector s that's 3i minus 6j. What's the vector t that's negative 0.5 times s? In other words, that scalar k is negative 0.5. Well, because it's negative, we know the vector t is going to be going in the opposite direction, 180 degrees away, or pi radians away from the direction of s. So vector t is going to be negative 0.5 times vector s, 3i minus 6j, which equals negative 1.5i plus 3j. Notice because of the negative side, both components change their direction. So what's the magnitude of vector t? First, to find the magnitude of vector t, we ought to find the magnitude of vector s. which is, using the Pythagorean theorem, the square root of the components squared and added together, which is the square root of 3 squared plus negative 6 squared, which is the square root of 45, or approximately 6.7. That's the magnitude of vector S. So the magnitude of vector t is 0.5, because it's really the absolute value of negative 0.5, times the magnitude of vector S. So it's the absolute value of negative 0.5 times 6.7, or approximately 3.35. Remember, magnitude can never be negative. So let's look at an example of riding a bicycle. Let's say you're riding your bike and you're riding it, pedaling at 12 miles per hour, but the wind's directly behind you. It's a good thing. So in the end, you wind up going 15 miles in 1 hour. So first of all, what's the magnitude of the wind? And what's the scalar multiple of the wind? How is it changing your performance? What's the scale factor? So if we represent you're riding the bike in whatever direction you're going at 12 miles per hour, U is going to be 12. So U plus the wind winds up being 15 miles per hour in the direction you're going. And let's just assume it's horizontal, so we strictly have horizontal components here. So U plus W is equal to 15. So to find W, if U plus W is 15, we're going to subtract U from both sides. W is 15 minus U, or 3 miles per hour. The vectors added together give you 15. So what's the scalar multiple of the wind? To find the scalar, we know that the wind is equal to K times the original magnitude of U. So we would divide both sides by the magnitude of U. So the magnitude of W divided by the magnitude of U is equal to the scalar that represents how the wind compares to what you're doing. So that's 3 divided by 12, which is 1 over 4, or 0.25. So scalar multiplication of vectors results in vectors that are dilated. They're either larger or smaller in magnitude than the original vector, and they either have the same direction if they're multiplied by a positive, or the opposite direction if they're multiplied by a negative.